All right. Hello, everybody. It's Sebastien from Enzyme at Work for another weekly podcast of What's Cooking. So what we care about in Enzyme at Work is all the topic related to sustainability, circular economy, collaboration, and science. The goal is to see what are the technologies and the people outside that are working on this topic and potentially to find ways to mitigate climate change. So this week we have another great guest, Lionel, and we are going to talk about let's say recycling, so incineration plants, from waste to energy, some general introduction from Lionel, and then we go more into this topic, which is refractory, which for me was quite new, but it's kind of, for me, my point of view, kind of central if we really want to understand all this whole industry works. And also we are going to talk about what it will look like in 5 years. Without further ado, Lionel, can you please introduce yourself? Thank you.
Hi, Sebastien. I'm very pleased to be here. Hi to everybody. My name is Lionel. I'm working in the refractory industry since 16 years with a feedback and education as an engineer. And since 8 years, I am dealing with strategic marketing. And the company I'm working is in the company Younger and Greater. We are a mid-sized company with 450 employees in Germany and in Europe. And we are generating 150 million euros revenue. And as I mentioned before, and as you say, the specialty of and the expertise of J&G is the refractory linings, where we make the design, the installation, and the supply of the refractory linings, as well as some expertise we provide to our customer to have a better performance of the lining itself and a better availability of the plants.
Okay. Very good. Thank you very much for this introduction, Lionel. So before we dig into the refractory, can you just give us a rough overview of how an incineration plant works?
Yeah, I mean, the main business, how do we come from refractory to incineration plants and waste management? The main business units of J&G are the environmental technologies. So you consider the waste to energy plants, and you can consider as well the industrial waste or hospital waste, as well as the wastewater sludge. So there are several processes to be able to handle the wastes out there. The major issue that we have with the waste is that just to give rough idea where's the waste coming from before I go into the waste incinerators, we have roughly 2 billion of tons of municipal waste worldwide that need to be handled, which is a trend that is growing, because unfortunately this trend is growing due to the fact that the population is growing. The stabilization we have now is that the waste generated per capita is being stabilized in Europe with around about 500 kilograms of waste per capita per year. As a comparison, in the United States, which is often taken as a bad guy in this area, they generate more than 800 kilograms of waste per person per year. With the growth of the population, we know that these quantities will increase, and that it will become a major issue for the future, especially in African countries. And the point is that for all these waste, we have 3 ways to handle this. The first one and the worst one is the landfill, which is basically what you see in more outside of Europe, where the waste is buried in the body, in the ground, or you put it in the ocean. It is a major issue because you have pollution of the ground, pollution of the groundwater. You have plastic in the ocean, which is what's a lot reported in the medias, and you have dramatic issues for the biodiversity. And of course, you need a huge space needed. So that's the point. In Europe, for a rough idea, we have 24% of the waste which is landfilled. In countries like Germany or Sweden, you have 1%. So they succeed in avoiding completely this open landfill. But in the United States, as we take the example in the past, 50% of the waste generated is still landfill. The second way is the waste to energy plants. So basically, the principle is to take out the energy involved in the waste that you have. This energy will be used to produce electricity or to produce public heat for habitations. The main advantage that you have first the valuation of the energy included in the waste, and beyond that, you have a thermal treatment of the waste, which kills and destroy all the bacteria and all the chemical processes that create some pollutions with direct landfill. On top of that, you have the residues of this incineration is 15% of the global amount. So you have a lot of savings of space, and you have the possibility to reuse parts of the material that you have in this residue that has not been burned. And the last part is the recycling. And the recycling, the main advantage is that you can reuse the resources that are included in the waste. Here, unfortunately, there is a big misunderstanding in the processes because, for example, the plastics, which is a common example taken, only 5% of the plastic that we recycle are indeed reused in finalized product like plastic bags or plastic glasses and so on. The main part is used as a subsidiary fuel, like in cement industry. So it still burns. The advantage of this sorting out is that you have no residues, so you can use completely the point, but it's still an incineration process where you use the thermal capacity of the products.
Okay.
So this is the global or the major perspective that I can propose here on the surface.
Okay, very good. Thank you much, Lionel. So we have the overall understanding of, let's say, where the waste are coming from, how they are being treated. So now let's go inside this waste to energy plant. Let's go in the place. So you have, I guess, some kind of input output. So there's some sorting like you mentioned, and then it goes into this space. I don't know what you call this space where it's being burned. Can you maybe dig a little bit more into this and then relate to what you do?
The refractory lining is refractories is by definition products and materials that resists against the temperature. So in all those processes, and especially in the waste to energy plants, where the temperature is getting beyond, let's say, 600 to 800 degrees, then you need to have some refractory materials. And the purpose for waste to energy plants is to be able to take out the energy and the calories from the waste, from the fire, and be able to transfer it to the boiler walls, where on the first part, steam is generated to collect the calories included in the waste. And the refractory lining is in the main area where the temperature are the highest, because the point is that the higher the temperature, the extremes are the chemical corrosions and chemical reactions on the technical plants, and the refractory lining is there just to protect and make sure that the plant is able to run continuously.
Okay, all right. And so I mean, you just said it helps the plant to run continuously. So it has a key structural usage in this plant. So can you maybe let us know what kind of material, how these things are, these ties, these refractory are being manufactured? Because I guess it's not simple things.
Yeah, I mean, of course, you are looking for special property for waste to incineration plants. We are working most of the time with silicon carbide. So you have to take sand and create some silicon carbide for its property to withstand this temperature and be able to transfer the calorie from the waste into the boiler walls. So this is the main material. The analogy that we often made is that the refractory lining for a waste to energy plant is a bit like the tires of your car. It's not the main part and main focus, but it's very strategic just to be able the plant to run. Of course, you have some wear, which is one of the core business. That part of the wear is being to be replaced every now and then, because in operation, then you damage the refractory lining, and you need to repair it every year or every second year.
Okay. What are, in terms of if you look a little bit at the history of your industry, your solution, I mean, so you've been talking about one specific material. Is there some kind of new materials that are helping, I don't know, to transfer more calories or to help the plant to do their job better?
I mean, from the materials available, I mean, there are no game changer that we have from the research and from the industry. There has been in the past 20 years already some big innovation, from standard silicon carbide to nitride bonded silicon carbide. So there are still some research to do it. But the major innovation that we have is on the system itself. Because you have the material that is used to produce the manufactured products that you put on the walls to protect it, or you can consider it as a system itself. And we work more on the global system with backfilling or back air system, ventilated system, to be able to protect in the more efficient way. The target, as I mentioned before, is that to reduce the wear as much as possible, because unfortunately the environmental impact of the silicon carbide is quite high, because it's a lot of energy to produce them. And the way to improve the performance as well for the costs and for the environmental aspect is to extend the lifetime of the lining itself.
Okay. And I know when we were preparing this podcast, you were also telling me that it's not easy to inspect this area of a plant, because you need to shut down the operation.
That's it, yeah. That's the point that we produce and that we develop using drones, using thermal cameras, just to be able to support the customer and be able to anticipate the work to be done. It's all the same. The mission of G&G is basically here for our field of expertise to make the availability of the plant as high as possible. So you can help statistically, you can make some analysis when the plant is running, just to make sure that the shutdown time is as small as possible, and that the overall cost of handling the waste is getting lower and lower.
Okay, thank you very much, Lionel, for that. So how do you see this whole, going back to kind of the macro view, how do you see this whole waste to energy processes, let's say in 5 to 10 years from that? Do you see big changes coming up, because the waste stream is going to be different in terms of volumes, in terms of mix, in terms of sorting, in terms of regulation, in terms of technology? Do you see big changes coming up in the 5 to 10 years?
Globally, something needs to be done. As I mentioned before, the amount of waste is growing. We have now already major issues on the global scale to handle the waste. I mean, some films that have been out there, like Slumdog Millionaire, or all the documentation that you see on this huge amounts of plastic collected in the oceans, in the Pacific Oceans, and being a huge problem for the biodiversity. Here, you have to make sure and develop the infrastructure. In the recent year, for example, last year we opened a huge plant in Dubai, being as the first waste to energy plant in Dubai, built by G&G. And some of our partners, they are still developing and gaining some new contract for big agglomerations out there, just to make sure that this landfill problematic is being developed and is being killed, because this is definitely the worst thing that you have. And globally, it's still the transition that started in Europe, let's say back in the 70s, 80s, we are now at a good level in Europe, but still out there, it needs to be a lot of things done and a lot of plants needs to be built just to be able to handle this. I mean, the perspective in Africa is getting, on the global scale, on the midterm, one of the biggest issue, because the waste per capita is growing in these countries as well, and they have almost no infrastructure just to be able to handle the waste. And as a technology experts, then we need to make sure that they can invest and equip their own agglomerations and cities into this waste treatments infrastructure.
So just to remind the audience why it's important, I think you said at the beginning that there was only in the US there was 50% of the waste being still landfill, and in the rest of the world, I forget the stats that you said at the beginning.
I don't have exact figures on this because it depends a lot on the country you are, and I do not have any other figures. I mean, you know, I know in Europe with 25% and around about 50% in the United States. So you still have this expansion of the infrastructure to do that. On top of that, I mean, you are still a leading zone in Europe, and we are very focused and very forward in comparison to other countries. And then we still need to work on alternative processes to reuse not only the energy in the waste, but to reuse the processes itself. So it's a development that the entire society needs to do, because you need to sort the waste just to be able to isolate the resources that you want to recycle. And on top of that, you need to develop the processes then to make sure that you're able to reuse it and make it in a good condition. There are a lot of innovation. We see our target and role just to support the plants designers and process designers, just to say, okay, refractory will not be an issue, and we work with you just to be able, as an expert, to tackle the refractory problematic coming with these processes. One example is, for example, the aluminum industry, where you say your can that you are drinking out, you can reuse it, you can melt it, and make a new can out of the old one. So this is one of the extreme processes. Of course, aluminum is a very good example because it works pretty well. And the target is to find the other raw materials that you can reuse and how to recycle them. It's the technology and the process that we have, and for the refractory itself is to be able, as well as an installer of refractory, to define an organization and a process that allows, when you dismantle part of the refractory lining, that you can recycle this material instead of using raw materials. For some part of the industry, like the steel industry, it's already in place because you have very big volumes and kind of a clean process. But all what is connected to waste, there is a lot of uncertainty and a lot of expertise and engineering work to be improved just to be able to collect and recycle all the materials. So this is definitely the focus that we have to put, just to make our processes and our fields become more efficient from the environmental perspective.
Okay, thank you much. I mean, it's we are slowly going towards the end of the podcast. Thank you very much for this high-level perspective, going down to the processes, to the material being used, and to, let's say, how this industry is going to look like in the future, and what kind of research is being done, needs to be done to tackle this big problem. I would like to thank you very much for your time. Thank you for this very clear explanation, because it could have been much more technical, and you managed to stay on a very clear understanding level. So thank you very much for that. For anyone that is interested about knowing more about refractory, I encourage you to reach out to Lionel. It will certainly help you and give you more information. And on my side, I would like to thank you, Lionel, again for being here today and for the people that are listening it. And we see each other again for another podcast, another great guest. And I wish you all the best.
Goodbye.